our second example of a first order differential equation, separation of variables. So our next problem is exercise 19 of page 25, elementary differential equation, 7th edition by Rainville and Pigeon. So you are asked to find the general solution of this equation. dr is equal to b times the quantity cosine theta dr plus r sine theta d theta. So as you can see, there are no initial conditions given. So we will no longer be looking for a particular solution, but rather the general solution. Now in this equation, we should be able to identify what are the variables and what are our constants. In this equation, we have dr and d theta. So it follows that our variables are theta and r. So all other characters here, like b, is assumed to be constant. So that is very important before you proceed in solving a first order differential equation, separation of variables, to identify first what are your variables. So the first step is simply to distribute b to cosine theta dr and r sine theta d theta. Okay, so this is our second step. First step rather. Then by inspection, you have dr in the left side and you have dr in the right side. So you transpose this to the left side so that you can combine the dr terms. So we have now transposed b cosine theta dr to the left side, and we have combined them with dr. Now, since dr is common, so we factor out dr, and we have now 1 minus b cosine theta, and the right side we just copy. Now, at this stage, you can already see how you are going to separate the variables. So you have dr, you have r, and you have b sine theta d theta, and you have 1 minus b cosine theta. So separating the variables will lead us to dr over r is equal to b sine theta d theta all over 1 minus b cosine theta. Now by inspection, the left side is an integral leading to logarithm, and since the right side is of the same form, we will try if indeed this integral will also lead to logarithm. So we will let our denominator as our u, and getting the differential of that will give us b sine theta d theta, which is actually our numerator. So indeed, this integral will also lead us to logarithm. So integrating both sides of the equation will give us ln of r is equal to ln of quantity 1 minus b cosine theta plus c. So combining the logarithmic terms, we transpose this to the left side. So it will give us ln of r minus ln of quantity 1 minus b cosine theta is equal to c. Now simplifying using the properties of logarithm, these two will now become ln of r all over 1 minus b cosine theta, since this is minus. In order to eliminate the ln here, apply anti-logarithm on both sides, so the equation will now become r all over 1 minus b cosine theta equal to e raised to c. Okay? Now, since e is a constant and c, the exponent, is also a constant, so this term here can be reduced to a constant c. So we can rewrite the equation now to r all over 1 minus b cosine theta is equal to c. And simplifying further, expressing our final answer in terms of r, so we have now r is equal to c times the quantity 1 minus b cosine theta, which is our general solution and final answer, and an answer similar to that of the book of Rainville and Bijan. So again, I hope you understand the solution to this problem. We will have our third and final example for separation of variables in the coming video. Thank you very much and good day.